Hi, let's talk about mass and weight. So let's get started. So, mass, as you're probably already familiar with, is the quantity of matter in a body, regardless of its volume or any forces acting on it. And we measure mass, or the SI unit for mass is kilogram, kg. All right, when we're talking about weight, the weight of an object is the force of gravity that is acting on the object. So we can calculate weight by using this equation. The force of weight is equal to mass times gravity. So we only have weight in areas where you have gravity. Gravity is the reason why we weigh like we do on Earth. So weight is a force, and so since it's a force, the SI unit is Newton. All right, number three. Which is the same no matter where you are in the universe? It would never change. That's going to be mass. So let's say that you have 75 kilograms for your mass, then you would have 75 kilograms for your mass no matter what planet that you step on in this universe. All right, number four, which depends on your location and can change from place to place and planet to planet. That would be weight. So weight depends on both mass and gravity. And gravity can change between planets. Therefore, your weight changes if you go to different planets. All right, so on Earth, a mass of 1 kilogram weighs about, well, let's calculate it. Remember, we have an equation to solve for weight. Weight equals mass times gravity. And so let's go ahead and plug in. So we knew that our mass was 1 kilogram. We knew that the gravity on Earth is 9.8 meters per second squared. So whenever you multiply it out, that would mean that the weight for this 1 kilogram object would be 9.8. And remember, weight is a force, so newtons. 9.8 newtons. All right, number six. Gravity on the moon is about 1/6 that of Earth. So here's your Earth. And Earth's gravity is 9.8 meters per second squared. And here's our moon. Our moon has a gravity of 1.62 meters per second squared. All right, so would it be easier, harder, or just the same to lift a rock? So we're going to be lifting a rock on the moon that was very heavy on Earth. So let's say that this rock maybe has a mass of 100 kilograms. That's pretty heavy. So it's going to have 100 kilograms on the Earth and on the moon. All right, so to lift that rock, you're going to have to apply a force, right? You have to apply a force to move anything, to lift anything. So to fight against gravity, you'd have to apply a lot of force on Earth. There is a huge amount of force pulling that rock towards the center of the Earth. 9.8 meters per second squared is the strength of gravity. But on the moon, it's just a little bit of gravity, 1.62. So it would be easier to lift that rock on the moon instead of Earth. All right, number seven. Would it be easier, harder, or just the same to push a heavy car on the moon compared to pushing it on Earth? All right, so again, you have a small amount of gravity on the moon, a large amount of gravity on the Earth. So to push that car, you're going to have to apply a force to fight that gravity, and it would be easier to push that car on the moon because there is less gravity on the moon to fight against. All right, number eight. We're going to start doing some word problems to practice calculating for weight and mass in different scenarios. So our first one. How much does a 2 kilogram object weigh? So we're going to need to use our original equation. Weight equals mass times gravity. And let's plug in what we know. So we're looking for weight, so we would W equals 2 kilograms is our mass, so we plugged in for 2 kilograms. And then our gravity on Earth is 9.8 meters per second squared. So when we multiply 2 times 9.8, we would find that the weight of the object is 19.6 newtons. All right, number 9. How much does a 5 kilogram object weigh? So again, same equation. Weight equals mass times gravity. Plug in, the mass is 5, the gravity is 9.8. And when you multiply 5 times 9.8, you get 49. And remember, weight is measured in newtons. All right. Number 10, how much does a 12.5 kilogram object weigh? Same equation. Plug in your numbers. Oh, I forgot to change that. That should not be a 5. That should be a 12. But the answer is correct. It would be 122.5 newtons. All right, number 11. What is the mass of an object that weighs 30 newtons? Okay, so now a little bit different. Now we're looking for mass. So before we were looking for weight. Weight equals mass times gravity. And now we're going to be looking for mass. So we need to get mass on a side by itself. So you could rearrange the equation first, or you could plug in, then rearrange. Either way is fine. So first I'm going to show you this way. So to get mass on a side by itself, we're going to divide by gravity. Cancels out. What we do on this side, we have to do on the other side. So we know that to find mass, we have to divide the weight divided by the gravity. So the mass is equal to, well, the weight was 30 newtons and the gravity is 9.8. So when we do that, we should get the same answer as plugging in then rearranging. So our original equation was weight equals mass times gravity. We can plug in our weight of 30 newtons, and then we're looking for mass, so we have m times 9.8, our gravity, divide by gravity on both sides, and we should get that the mass is 3.06 kilograms. All right, number 12. What is the mass of an object that weighs 70 newtons? So again, we're solving for mass. So we take that original equation, and we're going to solve for mass. So we're going to use mass equals weight divided by gravity. So the weight was 70, the gravity is 9.8. And if you'd like to do it the other way, that's fine. So weight equals mass times gravity. We plug in the weight for 70 newtons. Mass is what we're looking for. We plugged in our gravity, 9.8. So when we divide by 9.8 on both sides, it cancels out here. You end up with 70 divided by 9.8, and that's going to give you 7.14. So 7.14. Either way gives you the same answer. You're still doing 70 divided by 9.8 to get the mass. All right, what is the mass of an object that weighs 155 newtons? So weight equals mass times gravity. You're going to plug in the weight to be 155 newtons. We're looking for mass, plug in the gravity of 9.8. We're going to divide by 9.8 on both sides, so that way we can figure out what mass is. Cancels out on this side. We end up having mass equals 155 divided by 9.8, and then our answer is 15.8 kilograms. All right, number 14. A rock has a mass of 2.5 kilograms. So the mass, M, is equal to 2.5 kilograms. And we're talking about on Earth. So remember, Earth has a gravity of 9.8 meters per second squared. What is the mass of that object in the middle of outer space? So remember, mass never changes. Your mass is the same no matter where you go. So the rock's mass is still 2.5. No math was needed. As long as you know mass never changes, the mass is the same on Earth, on Jupiter, on the moon, outer space, the mass is the same. Number 15, a rock weighs 17 newtons on Earth. So now we have the weight is 17 newtons on Earth. And remember, Earth has a gravity of 9.8 meters per second squared. But the question's asking, how much does it weigh? So we would be looking for its weight in the middle of outer space. So we like to think that middle of outer space, there's no gravity, right? So weight can change based on where you go. So if we went to the moon, your weight would be a lot less. If we went to a larger planet, it would be a lot more. But we're talking about outer space. So outer space, there's no gravity. So therefore, the weight of this rock would be weightless. It would be 0 newtons. All right, so in summary, number 16, if you travel from planet to planet, your blank stays the same no matter where you are. Well, if we're talking about stays the same, we're talking about mass. All right, but your blank changes depending on the planet that you are on. Well, that's going to be weight because remember, weight takes into account mass times gravity, and gravity is what changes. So, mass stays the same, weight is what changes. All right, thanks for watching. Leave a comment if you have a question.